Hi, Mike. Are you feeling better? Can you hear me, Mike?
Hello, how you doing? Hello?
Hi, I can hear you, but you're really, really quiet.
Oh, sorry.
It's okay. I just turned my volume up, so. Are you feeling better?
Much better. Much better.
You ate some bad food, huh?
I think that was the case. Yeah, it was carried out.
Oh, yuck.
Yeah. So, yeah.
Never go that place again, huh?
Yeah, I'm done for a while.
Don't blame me there.
So, Lily's gonna join us tonight, right?
Yeah, I believe so. That's what I read. Hey, Ross.
Hey, how's it going?
Pretty good.
Good.
Oh, 4 different files to download this time. Might as well.
Yeah, there's like 30 questions or something.
Is there? Oh, great.
Yeah, 32.
Well, just get everything ready, and I'm sure Layla will be here. You guys all ready for the exam?
I think so.
That's good.
Yeah. I'm just not.
I'm not real confident about it. I'm in that 75% confident level.
Yeah.
That's double. Triple.
I don't know how long you think we should wait for Lele.
I say we get started and then if she shows up, we can kind of fill her in.
Okay. I think that's probably a good idea. Anyone like to offer the prayer, or shall I?
I'll say. Heavenly Father, we're thankful for this day and we're thankful that we're able to meet as a group. We guess that we'll be able to remember all the things that we have learned up to this point and that we will be able to do well on this quiz and be able to learn and teach each other as well. And we say this in the name of Jesus Christ, amen.
Amen. Thank you. Okay. I guess I'll start with number 2. Given a 90% confidence level of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? And I believe it's the second one. We are 90% confident that the true mean heart rate is between 45 and 105.
I think so.
Because when they say the confident, because I went to that meeting with the Adam this afternoon at 3, and he said anytime it says chance, you can pretty much put those out.
I mean, researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go and no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go and no-go stimulus required the student to respond to a particular stimulus and not to respond to the other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant, to determine whether the confidence interval will be reliable. They create QQ plots of random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? I think no, because the distribution of the mean of each sample is, or where did that go? Oh wait, would it be yes, because the distribution of mean of each sample is normal since the data have been determined to be normal?
That's what I would say.
Which one is that?
The third one, yeah.
Okay. Sounds good to me. 4. Of the 4 types of confident intervals listed below, which one is appropriate for this experiment? I think the third one. I think it's the third one.
Confidence interval for different means using independent samples.
Yeah.
I agree with that. It's first of all, you have to decide what kind of experiment it is to even be able to, if it's independent or dependent, right?
Yeah,
And so they were independent because it was males and females. So I agree.
right.
Yeah.
Let me just click on it.
Okay.
Question. A researcher is interested in estimating the savings account balance of customers at a large bank. He updates the savings accounts of a random sample of 30 customers. A 95% confidence interval for the mean Savings account balance of bank customers is found to be 34,002.08 to 41,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? And that would be the 99% confidence interval rather than the 95. Do you agree with that?
I do.
Yeah, I think so. Yeah.
Right. Okay.
All right. A factory makes propeller drive shafts for ships. The quality assurance engineer at the factory needs to estimate the true mean length of the shafts. He randomly selects 4 drive shafts made at the factory, measure their lengths, and find their sampling to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate 95% confidence interval for the true mean lengths of the shafts. Put your answers for the margin of error lower down at the bound. So determine margin of error for this 95%.
So, are you in the quantitative one or the inference or the descriptive one?
Would you just use a formula?
I think so, just because you don't have a whole table of data.
Yeah, darn it, I was hoping it'd be easy.
I know.
I think I left my formula downstairs. I forgot what it was.
So the 95% confidence. Is that 1.96?
Okay. The 99. You said 99 or 95?
95%.
That's that 1.960.
So that would be 1.96 times what was the mean? 1,000 over square root of no.
What was the formula again? Could you tell me? I forgot.
Yeah, it's margin of error equals the z-score times, and then this is in parentheses, times the mean divided by the square root of the sample size. Is it shown here a sample size?
No.
Oh, four. Four drive
Oh, there it
shafts.
is. 4. Yeah.
Okay. And I got 980.
Can you show how you did that?
I just plugged it into Excel. Let me see. It'll let me. Can you see my screen?
Yep.
All right, so this is the formula I put in there. The z-score for a 95% interval is 1.96. And then the sample mean was 1,000. Then you take the square root of the sample size, which is 4.
Mm,
Got 980.
okay. All right. All right. Input the lower bound. Number 7. Not sure how to do this. Um, okay. Just a second. So the formula I found needs a sample. There was no sample in this, right?
The sample size?
Huh?
The sample size?
Yeah.
Yeah, it says 4 drive shafts.
Yeah, 4.
Oh.
I actually forgot how to do this too.
I went back to I'm in lesson 11 in section 4. It has this thing on confidence intervals. But yeah. So I'm trying to do it that way.
All right, just open one more window.
So, just a second. So I got 998.04.
For the lower bound?
I got 998.04.
That'll be the upper bound. It's higher than the lower. It's higher than the other margin of error. I'm just throwing that out. I don't know because I haven't got there either.
I was in the lower bound, I thought.
Okay.
Hold on. The lower bound. I don't know if I did this correctly, but what I did was I took the 1,000 and I subtracted 1.96 and I multiplied that by 1 because the standard deviation is 2 and the square root of 4 is 2. Does that make sense?
Yeah. Let me.
This really should be easy because it's 0.5 points. But
Yeah, I think
it's been quite a while.
I think I got the margin of error around. That should actually be 1.960. That put the sample mean in instead of the standard deviation.
So you think the margin of error 1.960?
Yeah.
Okay, I'm trying to.
You said the margin of error is 1.960?
Yeah.
For number 6? For question 6?
Yeah, for number 6.
Oh.
And going off of that, then what you got for the lower bound would be 998.040.
998.040?
Yeah.
Oh, okay, that makes more sense. So the upper bound I'm going to be totally stuck on because I'm still trying to figure out how you got the other. And then if it's easy on when it's in the Excel, I can do it in a heartbeat.
Yeah, I'll show you on Excel real quick. So this is the upper bound right here. You take the sample mean that they give us of 1,000 and you add that to the margin of error, which is this equation.
Okay. So you minus instead of.
So on the lower bound, you minus
Minus instead of plus. Okay. Now I remember. Thank you. First do the parentheses though.
Yeah. Order of operations is important.
Yeah. Okay, so that's what I got for the lower bound, but the upper is I'm plusing instead of minus. Okay. Now I got it.
So yeah, the upper bound should be 1001.960.
Say it again.
I think he wanted you to repeat that, Ross.
What was that?
You repeat what you just said.
Oh yeah, so number 8 would be 1001.960.
Because you're adding the 1.96 to the 1,000.
Yeah.
Instead of minusing it.
Mhm.
Okay, I'm sorry. Would you say that one more time?
Yeah, 1001.960.
Okay.
Okay, since you answered that one, I'll shoot for number 9. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighing is computed. Suppose the scale reading are normally distributed with unknown mean and a standard deviation of 0.01 grams. How large should n be so that a 95% confidence interval where the mean has a margin of plus or minus 0.0001? I really did not bring everything up here. Okay.
This is like Greek to me. How do you solve that problem?
If you go to the lesson 15 reading, the review for exam 2, go to part number 2, the lesson summaries. And then there's a little thing off to the right that says show summaries. Click on that and go down to lesson 10 recap. And it's the last bullet point. It says the sample size formula. You find that?
Yes, I found it.
Good.
All right. I think it's, I'm getting B. I'm not sure. Probably doing it all wrong. What'd you get?
I'm putting it in right now.
No, wait a minute. I got that wrong. Let me look at something else.
What did you say you got?
I think I got 12,988. I don't know if that's right though, because I'm still,
I got 38,416.
I'm really using the wrong one. Where did you tell Mike to go for getting? Because I think I was looking at the wrong one.
I'll go to lesson 15, the unit review.
Ross?
All right, unit review.
And then you go down to lesson summaries, the part 2 of it. And click on the link that says show summaries. And then go down to the lesson 10 recap.
There it is. Okay.
Ross? What did you
Yeah, I got 38,416.
Yeah, that's what I got.
Okay. We'll go with that. I was looking at the wrong one. Okay, let me put it in 38,416.
Okay. The mean area of the several thousand apartments in a new development is advertised to be 250 feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and an alternative hypothesis for you are I think it's one, the first one.
So you want to find that, so you're looking for these alternative hypothesis to say that
It's small.
the mean area is smaller than 1250.
Yeah.
So it's two.
I take the bottom one.
Yeah, it'd be the last one,
So it's
because
four.
I always look at it as like the arrow thing. I always look at that as like a crocodile mouth. And it always wants to eat more, so it goes towards the bigger one.
So the mouth goes towards the bigger.
Yeah.
That's a good point. Good. Should make that. Okay, that helped me instead of having to look up the piece of paper all the time. It's like, what?
So then, yeah, it would be the fourth one saying that the alternative hypothesis is the mean is less than 1250.
Okay.
I'll write that down. Thanks, Ross.
Okay. All right. Question 11. In a statistical test of hypotheses, we say we reject the null hypothesis with the level of significance if, So we reject it if it is less than the confidence level or level of significance.
Yeah. So p-value is less than A.
Yeah.
This is really weird because I printed off these questions, the review questions. They're running in different than how they are on my paper. Okay. Okay, so number 12. A group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question? Right? Is this the same one? No. Let's see what I answered to it. That is really weird. It's just. I wouldn't answer these, and now I'm really messed up. Nope, I'm just gonna take a guess on what I think. Okay. I would believe yes. Because the bell-shaped and the no outliers. And the sample variances are nearly equal. Do you agree?
Yeah, wasn't the shape for the ANOVA test, wasn't that? I guess that would kind of still be.
Yes. Because it has an F statistic, it's right skewed. You're right.
Yeah, it's just really right skewed.
You're right. So it can't be that one. And I don't think it's the last one. I don't think we have enough data.
Okay.
Or do you think it's that we don't know the true standard deviations? I don't think it's yes, either one of those.
Out of all of these, though, I think that the third one is the most true, I guess.
The reason I said that is because they say they're nearly equal up there on top. And so I was going with the sample variances are nearly equal in both sentences. But you pointed out about the bell shape. So.
But I think that the ANOVA is still in a bell shape. It's just not like a symmetrical one, I guess.
Okay, well, let's go with that.
Which one?
Yes, that's enough that the data for each apartment building are bell-shaped. It's the third one.
The third one. Okay.
Yeah.
Question 13, a medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an parallel trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance levels. Consequently, she rejects the null hypothesis. In future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has what are the type 1 and type 2 errors again?
I think type 1 error is you're falsely rejecting the null hypothesis. Type 2 is, type 1, the null is true, and type 2, the null is false. That's how I've gotten it down. So I'm thinking it's a type 2 because it says that she's rejecting the null.
Yeah, that's what I think.
I think it's type 2 error.
So you said type 1, the null is true, and then type 2, the null is false?
Yep. Yep. Type 1, null is true. Type 2, null is false.
So what was the answer for this one? 13?
Type 2 error.
Type 2. Great. It's my turn.
Mm-hmm. It's your turn, Mike.
Froze. It's freezing. Why are you freezing? Okay. The level of significance is made very small, thereby making the probability of committing a type 1 error very small. What happens to the probability of making a type 2 error? Well, I think number 1. Okay.
Don't we increase the probability? I'm committing the type 2. I don't even know what lesson that was. That was long ago.
That was lesson 9.
Back in 9. Doesn't say increase or decrease, does it?
Mhm. It to me, it doesn't say either. Oh, okay. It says if the value, the probability of committing a type 1 error is very small. Of committing a type 2 error will be large.
So we increase the probability.
Conversely, if allowed to be very large, then the probability of committing a type 2 error will be very small.
So it would be that first one.
Mm-hmm. Yep.
Yeah. Yeah.
Okay, so question 15. The nicotine content in cigarettes of a certain brand is normally distributed with a mean and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5. The measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. HO null at 1.5, the alternative at 1 is greater than 1.5. At the 0.05 level of significance, you conclude that you should. It is you reject the null. Is that what you'd agree with? Reject if it's low, no, because the level of significance is lower than the 1.5. No, you fail to reject when it's a bit larger, right?
I think we have to find the p-value. Because then you reject or fail to reject off of the p-value being greater or less than the level of significance.
Say that again, what?
So we have to find the p-value because it's the p-value that you use along with the level of significance.
Oh, you're right.
If we fail to reject or reject it.
Okay. So that is in so this was before lesson, the p-value is the probability. My brain must be really tired because I've done this exam already today. And I didn't get this one. So, so the standard is 0.5. 7, 1.53 minus 1.5. Then you divide it by that.
Is it 7:30 where y'all are?
Yeah, it's 723. So did you get the p-value as 0.860?
I couldn't find out how to find it. What did you do?
Well, I did 1.53 minus the 1.5, and I divided it by the standard deviation. And then I got 0.176, then I put it in as the z-score, and I got the area, but I just don't know which side.
Shade.
Which side to shade. Then I'd get the answer. So it's saying greater than, right?
Yeah.
So that
Right.
0.43.
0.43.
Yeah, 0.430, yeah. So if they went back to the quiz, it's 1.5.
And then
So it's p-value is low, and the p-value is high.
yeah, it's higher.
Yep, it's higher. It's greater than. So we it's
So you failed to reject.
yep. Okay.
You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? I think that is either independent samples or paired sample.
Yeah, I agree with that. I don't think it's paired because they're not putting them side by side, right?
Yeah.
Because it says each group, doesn't say each.
Yeah, so I think it's independent samples t-test.
I agree.
Okay. What was the answer to number 15? I missed that one. Sorry.
Failed to reject the
HO.
No.
yeah.
HO. Okay. All right. Great. Number 17. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Hypothesis test based on independent or dependent sampling. It's dependent sampling. And I think it's the last dependent. Number 4.
I would agree. You have to include if you're going to do them both. All right. Great. Now I got to do all this. Okay. Use the following. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon levels of each sample. The measurements are recorded in the carbon thing. The researchers would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? Well, the confidence level is I believe it's when the mean is unknown. First one. Or not.
How did you get that one?
Well, didn't do any formula. It's just I reasoned it out. I don't know exactly what I did. I just know that when I was working it. Or when it's a random sample. So I didn't think they were dependent on each other or independent because is a random sample. And it wasn't given any information per se. I guess that's how I reasoned it out. I mean, I did do the work on it, but
You said number 1?
that's what I feel it is. What do you think?
I don't know. This is a hot one.
Yeah, I think that's good.
Do you agree with that, Ross?
Yeah.
And I mean, okay. Apparently I didn't save one along the way. That's right, I'll save it at the end.
Number 19, which of the following is the 95% confidence interval for this analysis? And put margin of error, lower bound, and upper bound. So determine margin of error for this 95% confidence interval. So I could get the quantitative where is that?
The inference one, right?
Yeah, I think so.
Okay.
Margin of error. So to find that, you just do the bigger minus the lower divided by 2, right?
Yeah.
So I got 2.025.
So was your confidence levels 11.168?
What was that?
What are your two confidence levels?
11.168 and 15.217.
Yeah, that's what I got.
That's what I got. I didn't get that margin of error though.
No, I think
Did you get that?
Did you divide by 2, Mike? So it should be 2. And margin of errors are never negative, so.
I got 13. Y'all didn't get 13?
How did you do that?
I added the upper and the lower and then divided by 2.
Oh, you subtract the upper from the lower.
Oh.
And so did you put it in as 2.2025?
Yeah, 2.025.
Yeah, that's what I got.
For the margin of error?
Yeah, that's the margin of error.
Would you say that number again?
2.025.
2.025.
Yes.
Okay. We've already.
Is it my turn or Mike's turn? I don't know whose turn it is. I'll just go. Input the lower bound, which the lower bound is 11.168.
And the upper bound is 15.217.
Now we have to get another data table up. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. That is recorded in that. We want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles Group 1 and Hummers for sale in New York Group 2. We get 95% confidence interval for the true difference of mean listing prices between the two cities. Of the 4 types of confidence intervals listed below, which one is appropriate? I think it would be using independent samples.
I agree. The third one, confidence interval for the difference of means using independent.
Yeah.
That's what I said.
I agree.
Okay, calculate the 95% confidence interval for the true difference of mean listing price between Hummers from LA and New York. Input your answers for the lower bound and upper bound. All right, I have to do all that still. Okay.
Now we go to the 2 sample 2 test, right?
Yeah.
Oh, because it's okay.
What was it, the prices?
Biennial.
Yeah, mean prices. Come on. Okay, so I got the lower bound is it's negative 4.423.238. Or did I do them backwards?
That's what I got.
Okay, because I did LA first. It was LA was the variable 1. New York is variable 2.
Okay. That's I must have done something wrong because I didn't get any of that. Versus variable 1.
Yeah, I did LA as variable 1. New York is variable 2.
And what type of test did you use?
The 2 sample test.
Oh, you didn't use the paired 2 samples.
No, because we're not doing a before and after scenario. We're just comparing 2 different ones.
Okay. Just a second, I'm gonna do that again. So what did you get, Catherine?
I messed up. Let me save my number. I messed up. Okay, I got what number are we on? I went back. I had to go back to something. 23. Okay. I got negative 423.238.
I did something wrong. That's not what I'm getting. Still.
What did you get?
Negative 3. I don't know what I've done.
Ross, did you get the same number I got?
Yeah, I got negative 423.
Okay. Mike, you want to just go with that?
Okay. Okay. And for the upper, I got 5417.336.
Yes.
What did you get? 5417.336?
Yeah.
Yeah, that's what I got. All right. Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random for the 3 groups. A control with no jumping, a low jump group. The jump height was 30 centimeters, and a high jump group, 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of rats was measured. The data are recorded in this research. Would like to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. Use a 0.05 level of significance. What is the correct hypothesis test for this situation? And that would be ANOVA, I think.
That's what
I
I'm,
think so too.
because of the 3 different.
Yeah. That's
That's what
what I was thinking.
Okay.
Great.
Calculate the test statistic. Oh, great. Okay, here we go. I think my computer's tired.
Yeah, I can relate to the computer. Your computer.
Yeah.
Or else I'm
It's
just.
where I'm at.
Come on. No, not that.
Is the test statistic the F?
Yes,
Gotcha.
I got 7.978.
That's what I got.
Sounds good to me.
Okay. Give the p-value. I got 0.002.
Agree.
What question are we on? Okay.
We did 27. Okay, so p-value is that. Is it my turn to do 28? Okay, I'll just do it. Which of the following best expresses the conclusion of this test? Use a level of significance of 0.05, and the p-value was 0.002, so that's the p-value is less. So
So it's less, so you
is less.
reject.
Okay, go ahead.
What did Mr. Lemon say? If you reject it, then you have sufficient, right?
Yeah, if P is low, reject the null. Low is sufficient. So it's one of the sufficients, and you reject.
I think it's number 3, because it's at least one of the groups. And one of the parameters for the ANOVA test or whatever is that at least one of the groups has a different mean.
Yeah. Wouldn't it be the fourth one because it's sufficient evidence? Because
Yeah, that's what I meant, the 4th one.
okay. Because there's the one group down there. Okay.
Yeah.
Okay. One more big one. I think it's just you and I don't know where Mike went.
Yeah. Here, I'll read that.
Okay.
Pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published tickets prices of one-way flights from Heathrow to various destinations in Europe were recorded for each scheduled flight 90 days in advance and then again 14 days in advance. Data are recorded in this spreadsheet. Perform a hypothesis test to determine if there is a difference in the mean cost of the non-stop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of 0.1 for the next 4 questions. Do 14 days minus 90 days for the analysis. What is the correct hypothesis test for the situation?
Isn't it a z-test because of you have the level of significance and the other ones you can't put the level of significance in? Is that true?
Let me see. And you do have a confidence of, yeah, I think so.
So you said a one sample z-test?
Yeah.
Would it be z-test or t-test?
I think a t-test.
I think z-tests are from earlier.
Yeah, in the beginning it said some of this is the comprehensive, so a few of them are going to go back to what we learned before. And then there'll be a few questions that will test us from Unit 1. I don't know, I'm just throwing this out, so. So you're thinking it's the sample t-test?
What's the difference between z-test and t-test again?
Z, I believe it's, you have the standard deviation there. Hey, look. Z-test, you know the standard deviation. The t-test, it's unknown. The sigma is known for Z. The T, it's unknown. So, did it give it gave us alpha.
Yeah, I don't
Yeah.
see, I don't see any standard deviation.
I don't either.
Then that'd be a t-test.
Yeah, it would make sense. It would be the t-test then. Okay.
The one sample t-test.
Yeah.
I got disconnected. What was the answer for number 29 or 28?
It was the fourth one down.
All right, I'll do 30. Calculate the test statistic. Great. That's really awesome. Okay.
Well, if you're doing a one sample thing, how are you doing the two different ones?
See, when I was thinking of it, I was thinking it was going to be the paired
Yeah.
sample test.
Yeah, because you have to do the two different ones. You can't do, it's not a one.
Yeah.
But it doesn't say paired. It says independent sample test or dependent.
I'm thinking it's dependent.
Well, I make, if there's two different things we have to do, it's definitely not a one, right? So, okay.
Yeah.
Okay. So,
So the dependent is that a
I
test?
think it's just a paired sample t-test.
it's a two sample test is the dependent, right?
I think the two sample test is the independent.
Oh, you're right. Okay. Now that you say it that way. Okay.
All right.
Okay. So you got to put it in the right order because it's asking for the 14 days first, right? And the 90 days after, the second one.
Yeah.
All right. I'm doing it now. All right. Okay. It asks for the what? Test statistic. All right, I got 1.685.
That's what I got.
That's what I got. All right. Give the p-value.
We
P-value.
have to change the confidence level to 0.90 instead of 0.95 though.
Oh, you're absolutely right. Thank you.
But I think that the T-score still stays the same.
Yeah, the t-score stayed the same. Okay. So the p-value, what I got was 0.096.
Yeah.
Yeah. So then that means that we would reject it. And that means that there is sufficient evidence that there is a difference, right?
Looking at the two.
Yeah, number 2 is what I think.
Yeah, that's what I would say.
Hey, we finished.
I think this was the longest one we've ever had that I can remember.
Yeah, it's the.
I'm okay with not doing this again.
Did anyone submit it?
I'm doing it now. It's
Okay.
just taking a while.
All right. So
That's an 88.
we missed 5. Number 5.
All right. Let me finish submitting mine.
13, 15, 21.
I got 21 right.
Oh. Excuse me.
Okay. So you said 5.
So I got 5, 13, and 15 wrong.
Yeah, I got 5 and 13. 15. Yeah. Okay. So 5 was not what I said it was. Okay. Okay. So 5 again. So a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings accounts of 30, 95% confidence, which would produce a confidence interval with a smaller margin error. Okay, it said I remember reading something about if you did either larger numbers or smaller, you'd get something different. Do either one of you remember anything like that? So if you only get 10 rather than 30, I don't think it will. Oh, let me shut down that. Bring back up this.
I'm gonna have to go. I have to get ready to go to work.
Where do you work out?
I work at the hospital, at the VA hospital here in Richmond.
Good for you.
Yeah, so I work at night.
We'll just watch the rest of this at the end at about what? However many minutes it'll be.
2 hours.
No.
All right.
We're We're gonna get this. Have a good night, Mike.
All right. Well, thanks for your help. Y'all have a good night. See
Thank
you
you.
Monday. Good luck on the
Yep.
test.
You too.
Okay. So only 3 questions. We can get this.
We're trying to get a smaller margin of error.
Yes.
So then you would want to have more of a sample size. So I think it would be the bottom one obtain the balances of 90 rather than 30.
Okay. That's why I was trying to remember. I remember reading something about one of those. It was either go smaller or larger. Okay, let's go for that one. Okay. And where's 13? Okay.
So this is the error. Let's see. Medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time for it is the same for the new treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at 0.05 significance level. Consequently, she rejects the null hypothesis. In a failure or in a future study, it is determined that the new treatment does not increase the mean
Okay.
survival.
I think it's that last sentence that does not increase. So she rejects, but it's not an increase. So it must be the type 1 because it's rejecting the null because it was true. And the null is, she's saying right there, it did not increase, so that was true. Would you agree?
Yeah, I think so.
Because I don't think in the significance level is not it.
Yeah.
So first one, okay. And 15, okay. Nicotine contents in cigarettes of a certain brand is normally distributed with a mean in milligrams and a standard deviation of 0.17. Brand advertises that the mean nicotine content of its cigarettes is 1.5. The measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this test, the hypothesis is that at the 0.05 level of significance, you conclude that you should.
So when you do a test, aren't you testing against the null hypothesis?
It is. So you never.
Because I don't think you ever reject or fail to reject the original hypothesis. You just do that for the null hypothesis, for the alternative hypothesis.
Adam said you never. What is it? He said never something the null hypothesis. So what you're thinking is which one?
I was going to say reject the alternative hypothesis.
And because you feel that you don't reject the null because.
Yeah, because I think you're testing the alternative against the original. So you're really rejecting your alternative hypothesis or failing to reject that.
Okay. I'm just trying to think sometimes if you have in the, when you're doing a test, I don't know if I remember it saying just reject HA, the alternative. But okay. We'll go with that, just so we can get out of here.
All right.
It's been a long day. Okay. All right. That was the only ones, okay? I gotta get back in. Did you resubmit it?
No, I have to put all the other stuff in.
Yeah, I do too. Okay. Well, we'll just take our chances.
Yeah.
Where did you go? Oh, it's taking my computer a long time. It's tired, I guess. Can't even get into the quiz yet. It gets tired. Come on. There we go.
We got 5 right on the second chance. We got 13 right on the second chance. And 15 is still wrong.
All right, okay. So maybe it's reject the null
Yeah.
instead. Okay. My computer's really slow. It's not letting me put in very fast answers. So thanks, Ross.
Yep, no problem.
Good luck on the exam.
Thanks, you too.
Thanks. And pray for me. I need it. All right. Take care.
Bye, you too.
All right. Bye-bye.
Mhm.